AutoScan captures the 3D shape of a real part, with no CAD model required. With a line scanner carried here by the robot arm, each pass sweeps the workpiece, and the Augmentus software stitches those passes into a single mesh you can build toolpaths on. Before you begin, 3 things need to be in place. First, you have to be working in an AutoScan project. In any other project type, the AutoScan function isn't offered at all. Second, the scanner must be mounted on the arm and connected with the robot reachable and in remote mode. And third, with a line scanner, the workpiece has to sit on the scanner's positive Y side. That's the one axis each pass can travel along. The workflow has 5 steps. First, add the AutoScan function. Set up the workpiece. Choose your scan and mesh settings. Plan the scan path. Then send it and decide what to do with the result. Start by adding the function. Open Add function, go to the Scan category, and choose AutoScan. Next, tell the software what it's looking at. Under Workpiece Settings, pick a shape and set its dimensions until it matches where the real part sits. It only needs to be a rough stand-in against the empty scene. You'll refine it against a real scan next. Open Scan and Mesh Settings and set 2 things. Laser exposure is how much light the scanner reads at each point. Raise it for dark, matte surfaces, and lower it for shiny ones. Then, the mode. Fast gives you quicker output at lower detail. Because the scanner is calibrated precisely, even a fast scan of the real surroundings is more trustworthy than guessing at a primitive shape. A good default for this first pass. Now the scan path. Scan axis stays on the robot here. Set scan path to linear, which sweeps in straight, parallel passes and suits large, flat surfaces. With the robot at your reference point, press Update under Key Scan Waypoint. Generate AutoScan stays grayed out until you do. Set the scan length, the number of scans, and the distance between them. The passes redraw in the viewport as you type, so you can check your coverage before the robot has moved at all. When the coverage looks right, generate the path, and the software works out the waypoints. Before you send it, press Plan. The software simulates the approach and steps through the program before the robot does. This fast pass plans out to under 2 minutes. Sending it puts a safety gate in front of you. Confirm you have simulated the program, checked for collisions, and have a hand on the emergency stop. Tick the acknowledgement, then accept and proceed. The robot runs the passes, one at a time. This footage is sped up. Actual length depends on the complexity of the scan, and the software stitches them into a single mesh. The scan is applied to your scene as the workpiece straight away, and you are asked to look at it before doing anything else. This one is thin, with gaps along the edge and holes where the scanner couldn't reach. That's a fast first pass, doing its job. You get 3 ways forward. Looks good. Use this mesh opens a new project with the scan as your workpiece. Edit Mesh first takes it into the Mesh Editor to clean noise, fill holes, or trim. And Continue Scanning to fill gaps. Adds a fresh AutoScan function so you can plan more passes over the thin areas. Since this scan has gaps, let's try again. This time with an arc path instead of linear. To reach the geometry, a flat sweep missed. Switch scan path to arc. It scans from several angles instead of one for depth and curvature. Set the length, the radius, and the angle range, and the coverage redraws as you go. And raise the mode to accurate. Higher detail for a slower scan, which is what you want once you already know the path is right. Same idea for the arc pass. Simulate it first, so you know the sweep is clear before it runs. Accurate mode costs more time, close to 4.5 minutes here. Same checklist, then accept. The robot runs the arc passes the same way. This footage is sped up too. Click Choose Next Step and take Edit Mesh first. Your current scene is preserved. In the Mesh Editor, select what is not the part, the fixture, the background, anything the scanner caught around it, and trim it away. What is left is the part itself, a clean measured mesh. Continue to New Project, and it's ready to generate a toolpaths on. Side by side, that's the difference switching to arc and accurate mode makes. The linear pass is thin with gaps where the scanner couldn't reach. Rerunning it as an arc pass in accurate mode fills most of that in. And that's AutoScan. One pass to see what you have, another when one angle isn't enough, and a mesh of a part that never had a model.